Hello students, friends and teachers. You all welcome to my channel, Government Ghosh channel. Kindly subscribe for better video. Today I discuss about the solution of question number 19 of exercise 5.1 chapter 5, the continuity and differentiability. In these questions we discuss the greatest integer functions related questions. This question is very important in the point of examinations. In CBSE examination, this question may comes in 4 marks. So the question is, so that the function defined by gx equal to x minus x greatest integer is discontinuous at all integral points. Here this one x greatest integer is denote the greatest integer less than or equal to x. So what is the meaning of this one? This one means it is must be an integer and that will be greatest integer which is equal to x or less than x. So we first solving or we define or explain about the x greatest integer, what its meaning. You may understood or may not understood, so I clarify this. But this is not necessary when you are solving, just your understanding, I will clarify this. The greatest integer function x is defined as the greatest integer less than or equal to x. So it must be a integers and that integer is less than or equal to x. This is the condition. So if you will take any number between 0 and 1, between 0 and 0 less than equal to x less than 1, then x greater than value will be 0. So example, greatest integer of 0.8 is 0.8 will lies here, then that value is 0. 0.1 is lies here, 0.2 is lies here, and 0 is lies here. Its greater than value is always 0. So you see from close interval 0 to 1 the value is 0. Close interval from 0 and open interval at 1. So this is the interval from 0 less than equal to x less than 1, the value is always 0. Similarly, when the value is from 1 to 2, 1 less than equal to x less than equal to 2, that value is always will be 1. So greater than the value of 1 is 1, 1.2 is 1, 1.8 is 1, 1.99 also 1. So that means from 1 close interval to 2 open interval is always value is 1. Similarly, when you take the other value, say when x is lies between 2 less than equal to x less than equal to 3, between this, so that is close at 2 and open at 3, close at 2 open at 3, that value is always 2. Say example, greatest integer value of 2 is 2, greatest integer of 2.001, that lies here, that also this is. Likewise you take any value between 2 less than equal to x less than, between 2 close interval to 3, that value is always 2. Similarly, you come to this sides from minus 1 to 0. Minus 1 is closed, 0 is open. Between minus 1 to 0, the value is always minus 1. So from this side you see the what number you will take, in that up to that number the greatest integer is minus 1. So you take minus 1, minus 0.9 is here, minus 0 point is here, 0.0 minus 0.001 is here near to 0. Its greater value is always minus 1. Similarly, you take the value between minus 2 to minus 1. Minus 2 close interval and 2 is open interval. In that case, the value is always minus 2. Say minus 2 greatest integer is here, that is 2, minus 2, and minus 1.9 lies here, the value also minus 2, minus 1.5 is lies here, that value also minus 2, minus 1.001, just right of the minus 1 is minus 1, that value also minus 2. Now see a simple thing. So we always taken that h is a very small positive number. H is taken a very small positive number. In that case, then what will the greatest integer? Value of h is 0, because h is lies here. You see, h is very small positive number, so that will lies here, nearer to 0, very near to 0. So its value will be 0. You see. Similarly, minus h is lies the left side of the 0. So in this case, the greatest integer less than minus h will be minus 1. So you see that is minus 1. So 2 minus h. 2 minus h means 2 less very small number. That number will be, what will become that number? That number will be nearly 1.999. Then its greatest integer value will be your 1. So you see 2 minus h will lie here, this side. So what will the greatest value of that is? That value is say 1. So you see 1. Similar 2 plus h. 2 plus h means 2.000 say 1. Very small number. That is 1. Very small number which is greater than 2. So that number is lies this side. This side, this side. So what will the greatest integer? 2. Be careful. You see the h greatest integer is 0, minus h greatest integer is minus 1, 2 minus h greatest integer value is 1, 2 plus h greatest integer value is 2. Now we discuss question number 19. The before what we discuss our greatest integer is no need to write in your solution. Just your understanding, we explain about what is the greatest integer function. How you can find the value of a greatest integer number. Now we come to the question number 19. So in question 19, the question is gx equal to x minus x greatest integer. This is the question, and so that this gx is discontinuous at integral points. So you want to clarify about what is the integral point. Integral point means the integers points, all the integral values. So integral value means all the negative integers 0 and all positive integers, means minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5 . So we have to check the discontinuity of this gx function at all integral points, means all integer points. So you see here integral point means the integer numbers, or k be any integers, k belongs to z. This is the meaning of integral points. Now you take a number k be any integral points or integers. We have to check the left hand limit and right hand limits and function value at this point, and these are not equal to each other. Then we can explain this is the discontinuity. Now you find the left hand limits. The left hand limit extends to k minus gx. So k minus means the very small, if this is the number lines, and this is the k, and k minus h means this side point. So this is called left hand limits. Then how much small? That is h small. H small means k minus. So limit x tends to k minus h gx. So its working formula is limit h tends to 0, g of k minus h, g of k minus. Then you put this g k minus h in this function, in this case. Then what is gx? X minus x. So gx minus k means here you put the x k minus h, here you put the k minus. Then what happened? Limit h tends to 0, k minus h minus k minus h greatest integers. So you have put in the value of k minus h here. Then that happened k minus h minus k minus h. Then this is the numbers. You see k minus h. You take a very less number of the integers k. So k minus 0.00, so that will be less than k, and that will be integers less than k. So less than k integer means k minus 1, k minus 1. So its value will be your k minus h greatest integer will be k minus 1. If you take say 3 minus h means that is 2. Similarly, if you will take say 4 minus h, then that will be your 3. So this time number will come. So when h will be subtracted from k minus h, that will be your k minus 1. So here that happen, k minus h greatest integer will be k minus 1, and that will be as usual. Now there is no need to simplify more, so you take the limit h tends to h value is 0, so k minus 0, and open the bracket here, minus k plus 1, then k and k cancel, then what happen, that will be your 1. So this is the left hand limit, so left hand limit equal to 1. Left hand limits equal to 1. Next we have to take the right hand limit. So right hand limit x tends to k plus gx equal to limit x tends to k plus h, gx equal to limit h tends to 0 g of k plus h. So this is the working formula. You see, when we take the right hand limits, so this is the k, and we take k plus h means this is, so this is called the right hand sides. So this is the function, then its working formula is this one. So that is limit k tends to 0 g of k plus h. Then you know the function, that is gx equal to x minus x greater integer. So in place of x you put the k plus h. So that is here x, in this case that is here, so you put k plus h, in this k plus h greatest integer. So what is the value of k plus h greater? K plus h is a very small position, so you take 0.001. So if you added with this, that number will be 2 something more, so the integer will be k. So likewise 2 plus k, so it is a very small added with the 2, so that will be always 2. If you take the minus 3 plus k, then that number will be minus 2.99, so that is again, that is minus 3. So this types the number will be your k plus h greatest integer will be your k. Then what happened, k plus h minus k. So open the bracket, so and substitute the value of h as a 0, so k plus 0 minus k equal to k cancel, then that will be 0. Then what is the functional value? The functional value of gx is gk. So in place of x you substitute the value k, so gk will be k minus k greatest integer. K is a integers, so greater integer will be k, so k minus k equal to 0. So what happened? We get what we got? We got left hand limit is your 1 and right hand limit is your 0. So left hand limit is not equal to right hand limit. Since left hand limit is not equal to right hand limit, so gx is not continuous at the integral points k. K is any arbitrary integral points. So the function is discontinuous at any arbitrary integral points k. So this proves gx, which is defined as x minus x greatest integer, is discontinuous at integral point. Thank you.